This section is a design overview, but it's really about what happens when a web app's design and build don't line up. The intended experience is simple. From the main page, the user clicks something, gets taken to a second page, and that second page contains a form. Today's work is about making sure that flow actually works after recent changes and a new build. The speaker starts by contrasting 2 days of work. Yesterday was about building the design itself. Today's task is behavior. When the user clicks, the app should navigate to another page, and on that destination page, there should be a form. This is a common shift in front-end work, moving from static layout to interactive flow, where routing and page structure matter. On the destination page, the expectation is a form. The speaker specifically mentions a piece of content like book a career consult, and is unsure whether it was removed or kept. That's an important real-world detail. Sometimes the bug isn't a broken feature. It's uncertainty caused by changes. Something might have been deleted, commented out, or not included in the build. A major symptom described is that the page keeps spinning, like a loader that never finishes, or a loop where the UI keeps trying to load. The speaker treats it as something that must be fixed, even calling it extra and slightly outside the main topic, because leaving it can cause problems on the server later, like repeated requests, timeouts, or the site appearing down. The speaker explicitly says this isn't completely part of the planned topic, but it still needs to be corrected. That's a useful engineering habit. If something is clearly broken and could impact deployment or server stability, it's often worth addressing immediately rather than pushing it forward and letting it become harder to diagnose later. A key technical point is that when the build is changed, the update needs to happen in 2 places. This usually happens when a project has 2 deployment targets, 2 directories that serve content, or a duplicated structure, like one for a root build and another inside a public directory. If you update only one, you can get mismatched behavior. One path serves the new code, while another still serves the old code. The first concrete action described is go to the same path as before and place the zipped build there, basically replacing or updating the build artifact. This is one half of the fix. It's a very typical workflow. You generate a build, zip it, and then copy it into the directory that the server uses to serve the site. Then the speaker notices they were outside and points out the second location. Inside the project, under the public directory, there's another copy or another place that needs the same update. The key idea is consistency. If the build is duplicated across 2 directories, both must be updated so the server doesn't serve mixed assets or outdated files. At this point, the speaker describes a confusing situation, looking around and feeling like there's nothing there or that they're going in circles. In practice, that often happens when you're in the wrong directory, the build output isn't where you expect, or the server is configured to serve from a different root folder than the one you're updating. The speaker makes an important diagnostic statement. The routes were not changed. That means the navigation logic, like the URL paths or route definitions, should still be correct. When you can confidently say something didn't change, you can narrow the search. If clicking still leads to problems, the cause is likely not the routing configuration itself. They also mention the API. Even if something changed in the API, it might not matter for this particular problem. The speaker suspects the issue is more on the layout side, meaning the front-end rendering, structure, or scripts, rather than the back-end endpoints. This is another key debugging technique. Separate back-end failures from front-end rendering or loading loop failures. The speaker points to the header as a possible source of the issue and mentions a script that might be commented out, something like a stack script. Headers often include global scripts, analytics, widgets, or loaders. If a script is broken, duplicated, or misconfigured, it can cause repeated reloads, long waits, or a spinner that never stops. Instead of relying on just one machine, the speaker asks someone else to try it. Open the Code IT website and see if it keeps spinning. This is a practical step. Reproducing the issue on another device helps determine whether it's a local caching problem, a network issue, or a real deployment problem affecting multiple users. The responses are inconsistent. One person reports it's been spinning, another says it's not spinning on their side. Then there's a note that it eventually stops loading. In debugging, inconsistent results often point to caching differences, CDN or server load balancing, intermittent server performance, or race conditions in the front end. The speaker escalates the concern by describing cases where it feels like 10 out of 10, meaning it happens every time. They even mention 100 out of 100 as a way to say it could become constant, making the site look temporarily down. That's a reliability red flag. Even if the app works sometimes, frequent stuck loading can be as damaging as a full outage. The speaker suspects the server is overslow. A slow server can easily create the exact symptoms described: pages that keep loading, requests that time out, and sometimes the front end retrying or waiting indefinitely. At this point, the next step is to inspect what's happening server-side: logs, response times, and whether the server is struggling under load or misconfiguration. The first thing to notice in this situation is the pattern of symptoms. The page sometimes keeps spinning as if it will load, sometimes it stops, and the observer even mentions a kind of 10 out of 10 state, basically implying the server looks maxed out. When load is that high, it's common to see intermittent behavior. One moment a request works, the next moment it times out. And importantly, when the system is pushed hard enough, there's also a real chance of temporary downtime, meaning the service can drop briefly and then come back. A very common reaction when a site suddenly becomes slow is to suspect an attack or hacking. But in this conversation, the more grounded explanation appears quickly. Someone had already made changes earlier. That's a key troubleshooting mindset. Before assuming a security incident, confirm what changed recently. They specifically mentioned something about JavaScript, like some script being added or modified. Even small front-end script changes can trigger big performance problems, especially if they cause heavier requests, repeat calls, or errors that keep the page stuck loading. Another important detail is the reasoning. Someone thought it's slow locally and then still placed it on the server. That's a risky move. If something is slow in a local environment, it usually means there's an inefficiency, like heavy JavaScript, unoptimized queries, large assets, or repeated requests. Deploying that without isolating the cause can amplify the issue in production, where real users and real traffic multiply the load. So this slide is highlighting a classic mistake pattern, treating deployment as a test, instead of validating performance before pushing changes. A key troubleshooting step is scoping. Is the issue happening everywhere or only on one page? Here, the question is raised directly. Maybe it's only the home page that has the loading problem. That's valuable because it changes the investigation. If only one page is slow, you focus on what that page uniquely loads: its layout template, scripts, images, API calls, and any special components. If everything is slow, you look more at global server health, database performance, or infrastructure. The conversation then distinguishes between two areas: the student portal side and the front-end public-facing side. The implication is that the student portal is not experiencing the same loading issue, while the front end is. That's a strong clue. It suggests the server isn't universally broken. Rather, something specific to the public front-end path is causing the slowdown. This could be a different layout, different assets, different caching rules, or different back-end endpoints being called. Now we get a very concrete technical clue. The front end uses a separate layout, meaning a different template structure than the student portal. That matters because layout files often control shared scripts, shared headers, shared CSS, and common components. If someone changed the front-end layout, like adding a JavaScript file, adding a widget, or changing how resources load, then only the front-end pages would be affected. Meanwhile, the student portal could remain fine because it's using a different layout pipeline. Given all of those clues, the most logical next direction is to inspect recent changes specifically in the front-end layout. The conversation hints that someone changed something earlier, and JavaScript is mentioned as a suspect area. So you'd look for new script includes, scripts that execute immediately on page load, and any code that could cause repeated requests or heavy computation in the browser. The goal is very specific: explain why the front end is slow while the student portal is not. In the next part, the analysis would naturally move into pinpointing the exact change and validating it by testing or rolling back. The key idea here is that the project uses separate layouts for different parts of the system. The public-facing front end has its own layout, and the student portal or dashboard side has a different layout. So if someone is checking the student portal and expecting a front-end layout change, they may think nothing happened because they are looking at the wrong layout. When debugging or testing UI changes, the first step is confirming which layout you are actually editing and which part of the site you are viewing. A practical problem discussed here is that layout changes on the server may take time to show up. Even after editing code, like commenting out a component, you might still see the old header or footer when you refresh. That delay can make debugging confusing because you cannot immediately tell whether the change failed or whether the server is just slow to update. The workflow becomes change code, deploy, wait, refresh, and then verify carefully. They also connect the slow update problem to hosting quality and support. With some providers, support is responsive. They can open cPanel, check logs, and changes reflect quickly. With others, support may be hard to reach, and even simple issues take a long time. The lesson is not just technical, it is operational. When choosing servers, it is worth discussing support responsiveness, how quickly deployments reflect, and how problems are handled in real time. A specific provider is mentioned, NAS Nepal, and the experience described includes several red flags: temporary downtime, support problems, and even the server having outdated code. That caused a serious workflow disruption. The developer's code became inconsistent. They deleted the server code and re-uploaded from local, and there was also mention of database data being lost. The takeaway is that hosting issues can directly cause code and data integrity problems, not just slow page loads. They point out an important distinction. If the homepage code is deleted, it can often be recovered from Git, but environment configuration, like the .n file, is not in Git, and the database is not automatically recoverable either. So version control protects code, but it does not automatically protect secrets or data. That is why backups and proper deployment practices matter, because losing database data is much harder to fix than restoring a Vue file. The debugging approach used is classic isolation. In the front-end layout, the header and footer are components. If the page is slow, broken, or not updating, comment out the header code and footer code, deploy, and see what happens. Then add them back one at a time. If the page works with only the header, the footer is likely the problem. If it fails with the header alone, the header is likely the problem. This is a fast way to locate the source of a layout issue. They reference how components are used in the layout, including the idea of a slot. The layout wraps the page, header at the top, footer at the bottom, and the slot in the middle where each page's unique content is injected. This pattern keeps the UI consistent while still letting each page define its own content. When debugging, it also means header and footer are common failure points because they load everywhere. They suspect the footer because it may contain JavaScript, things like pop-ups and interactive behavior. A small mistake, like an infinite loop or forgetting to close a loop properly, can cause the entire page to hang or load extremely slowly. Since the footer is included across pages, that bug spreads everywhere. So when performance suddenly drops after a footer change, it's reasonable to inspect scripts and repeated logic first. A practical move they make is to comment out the suspicious code, like the pop-up functionality, so the site becomes stable again. This is a good real-world habit. Stabilize production first, then do deeper investigation. They also mention that something looked only slightly slow locally, but after deploying to the server, it became noticeably slow, which can happen due to server resources, caching, or different runtime conditions. They also notice a spelling issue, like writing technical instead of technical. This seems minor, but it affects credibility and user trust. It's also a chance to distinguish static versus dynamic content. Static text is hard-coded in the Vue and can be fixed directly. Dynamic content is stored in the database and rendered from there, so fixing it might require updating records or admin panels. They confirm the stack. Laravel is used across the system, including the admin or student portal side and the front-end side. For styling, Tailwind CSS is used, and there may also be additional custom CSS. It's common for real projects to mix a utility framework like Tailwind with a small amount of custom styles for special cases. They compare Bootstrap and Tailwind. Bootstrap gives you pre-built components and a quick start, but customization can feel limited unless you override a lot of styles, and many Bootstrap sites can look similar. Tailwind is utility first, so you build designs by composing classes, which gives much more control and customization. Both are CSS frameworks. The choice depends on how much design flexibility you want and how your team prefers to work. When asked which is more lightweight, the response is essentially that they can be similar, because lightweight depends on how you build and ship your CSS. If you include large, unused parts of a framework, any framework can become heavy. The better mindset is ship only what you need, remove unused CSS, and measure the real output size rather than relying on assumptions. They discuss a specific Tailwind concept, shadows. In Tailwind, adding a basic shadow is often as simple as adding the class shadow. If you want the shadow to appear on hover, you can use hover/shadow. This is a good example of Tailwind's utility approach, small, readable classes that map to specific CSS effects. A confusion comes up. Someone expects shadow on both top and bottom, but only sees it at the bottom. The explanation is visual. If the element is flush against something above it, there's no visible space for the top shadow to show. The shadow may still exist, but it blends into the adjacent area.
the bottom shadow is more visible because there's open space below. So often, you don't need a special shadow bottom, you need spacing or separation to make the shadow visible.
They mention a workflow habit. Instead of manually browsing folders, use the editor's search to jump to files like an index page. The same approach helps when looking for Tailwind classes. Search for shadow and you'll quickly find where the styling is applied. Efficient navigation matters a lot once projects grow beyond a few files. The next development step they plan is a simple navigation flow. When the user clicks a button, it should take them to a new page called something like Book. That page will contain a form. The plan is staged. First build the page in form, then later connect it to database saving. This is a natural way to build features. Get the UI and routing working before wiring persistence. To navigate to a new page, they describe creating a new view inside the Views folder, like book.blade.php. The exact name can vary, but meaningful naming helps. Then the button click should be wired so it renders that view. They also mention that if you see errors like connection failures, that's usually an environment issue, so you may need to check server configuration rather than assuming the view file is wrong. They clarify the bigger learning goal, not just making pages, but learning CRUD: create, read, update, and delete. A form page, like Book, is typically the entry point for create, where a user submits data. Later, you build pages to read and list records, then edit them, and finally delete them. Keeping CRUD in mind helps you design the flow correctly, instead of building disconnected screens. They emphasize planning. If you are only building a front-end prototype, you can simply navigate to a form page and stop there. But if you are building a real application, the form must submit to the backend and save to the database, and you need to implement the full CRUD cycle. This decision affects how you structure routes, controllers, validation, and database tables. From here, the natural continuation is to implement the route to the Book page, build the form fields, and then look at the code needed for form submission. After that, the database save logic for the create step can be added, and then the rest of CRUD can be built out. The next section should focus closely on the form code and how it connects to backend logic. Continuing from the earlier idea of submit a form, the instructor shifts the flow on purpose. To learn CRUD properly, the user should land on a table page first. That table is where the app reads data from the database and shows it as a list. From that list, the user can create a new record, edit an existing one, or delete one. So the table becomes the center of the learning flow. Read happens there, and create, update, and delete are triggered from there. On the table page, the app shows a booking list, basically rows of data that were saved earlier. The instructor mentions things like a serial number and the fields that will be stored in the database. The important point is, this is a UI table that displays database data. Each row ends with action buttons, typically edit and delete, because those are the entry points for update and delete operations. A student asks whether the table means the database table. The instructor clarifies, no, this is a front-end table, a user interface element. It's built from data that comes from the database, but the actual database table lives inside the database system and isn't something users directly open and browse. In practice, the application fetches records and renders them into this UI table. The instructor distinguishes the two actions clearly. Edit is a navigation. When you click Edit, you go to a separate edit page where a form is shown, you change values, and then you update the record. Delete is different. Clicking Delete typically performs the deletion immediately without taking you to a new page. A student asks about a confirmation pop-up. Yes, that's possible, but it's not considered a separate page, and the instructor postpones it for later. Also in this flow, delete is treated as permanent. When the instructor counts pages, the conclusion is, for a basic CRUD interface like this, you typically need 3 pages for each resource. 1 page to list records, the table or index page, a second page with a form to create new records, and a third page with a form to edit existing records. Delete doesn't get its own page because it's triggered as an action from the list. Next, the instructor explains a practical problem. Booking is only one resource. Real projects have many: courses, admissions, students, and more. If each one needs 3 pages, index, create, edit, and you dump all those files directly into one views folder, the folder becomes huge. Over time, it becomes difficult to find the right file and maintain the project. The instructor's solution is to group pages by resource. Inside the Views directory, create a folder like Booking and place the 3 pages inside it. The naming convention is also important. The list page is commonly called index, the create form is create, and the edit form is edit. This structure scales well because each resource has its own folder, so finding files stays easy. Now the instructor starts implementing the index page. At this point, the focus is not on showing real data yet. Instead, they build the structure, a section, a container, a heading like booking list, and a link or button labeled Add New. The table itself can be added later. Right now, the goal is to establish the page layout and the navigation to the Create page. A key rule the instructor emphasizes is if you create a page, you need a route to view it. For the booking list page, the route can be something like /booking, and because the file is inside a booking folder, the view name should be booking.index. If you wrote view.index, the framework would look for a top-level index view, not the booking folder's index.
The instructor also comments on URL formatting. You could technically expose the index page as /booking or /booking/index. In most projects, /booking is the cleaner convention. The main point is consistency and readability. They also mention that URL choices can matter for things like SEO and overall clarity, so it's worth forming good habits early. While adjusting the page, the instructor focuses on UI consistency. If one page uses a certain spacing, like a section padding class, other similar pages should use the same spacing so the site feels uniform. They tweak padding values like PY5 and also consider bottom padding. The idea is don't let each page drift into its own random layout. Keep a consistent design system.
A student asks a practical question. Normally, CSS is stored in one place, so what's happening here? The instructor explains that during development, a command is running that serves or compiles the styling live. If that process is stopped, the styling can stop working, meaning the design you see may disappear. To store assets for production, you typically run a separate build command that outputs the final compiled files.
For the Create page, the instructor reuses the same layout pattern, but changes the meaning. The heading becomes Create Booking, and instead of an Add New link, the right side button becomes Go Back, which should return to the index page at /booking. The form itself will be placed below, but first they make sure navigation between pages is correct. Just like the index page, the Create page needs its own route. The instructor creates a route such as /booking/create and points it to the booking.create view. They stress that every page you add needs a route, and the URL should be distinct so the app can navigate correctly. The instructor points out an easy mistake, using the wrong link. If the Go Back button on the Create page points to /booking/create, then clicking it just keeps you on the Create page. The correct destination is the index page at /booking, so you need to be careful and intentional with URLs. Use the link that matches the page you actually want to reach. The instructor briefly connects URL structure to broader concerns. Clean URLs like /booking and /booking/create communicate meaning. This is the booking resource, and this is the create action. That clarity helps users and developers, and it can also influence SEO. The deeper SEO discussion is postponed, but the habit, clean, consistent URL naming, is emphasized right now. Right as the Create page is being prepared, the instructor sets up the next topic, forms. They mention that forms commonly use two methods, get and post. Get is usually for requesting data, and post is typically for submitting data to create something new. The instructor notes they will explain the form tag and form methods next, since the Create page will rely on a form, usually using post. Continuing from the idea of forms, a form is basically a way to collect input from a user and send that input to a server as a request. In HTML, the form usually uses one of two common methods, get or post. The key is to connect the method to the goal. Are we trying to retrieve information, or are we trying to save information? Get is used when the user fills a form because they want to get something back, like search results or filtered data. A classic example is a search box. If someone types a name like Depeche and clicks Search, the intention is not to store the word Depeche permanently in the database. The intention is to send a request and receive matching results. Another easy way to think about get is the user is asking the system to show something. For example, searching for a course like Laravel. The important part is that the user expects data back from the server, results. Even if the system logs the search internally, the main purpose of the form submission is retrieval, so get fits naturally. Post is used when the form data should be sent to the server to be saved. In other words, the user isn't just asking to see information, they are creating something or submitting something that should be stored. So the flow is fill the form, submit the data, the server receives it, and then the server saves it in a database or some storage. A simple rule of thumb is if you're retrieving data, use get. If you're saving or submitting data, use post. Search is the typical get example, and things like booking, registration, or submitting a form to create a record are typical post examples. This is a convention, meaning it's the standard practice developers follow to keep systems predictable and consistent. One important point, get and post are part of HTTP, and they're conventions we follow. Technically, you could use post even when you're just retrieving data, and you could use get even when you're submitting data. Usually, it won't instantly break, and it won't necessarily throw an error just because you chose the wrong one. But developers avoid mixing them because conventions communicate intent and make applications easier to understand and maintain. Now, apply the rule. If the form is for booking a consultant, the correct method is post. Why? Because the user is sending details that the server needs to store as a booking. Even if the server sends a response back, the main purpose is to submit and save the data, so post is the natural choice. Next, instead of focusing only on the form tag itself, the focus shifts to the tags that go inside a form. A form is a container, and inside it you place different elements that collect user data. One of the most common and important ones is the input tag, and there are other form elements as well. The input tag is the basic building block for collecting typed information. When someone needs to enter normal text, like a name, a keyword for search, or any short text, you typically use an input field. It's that familiar box where the user clicks and types. Inside a form, one of the most common tags is the input tag. The input tag is basically the field, the box, where a user can type something in, like a name, an email, or a phone number. So when someone says input, think a place where data is entered in a form. Sometimes when an input is added, it may look like nothing is there, especially if there's no border or default styling applied. But you can still notice it because when you hover, the cursor changes, showing there's an interactive field. If you want it to be clearly visible, you typically add styling, like a border, often through a class. In many code editors, you don't need to type the full word input. If you type something like imp and press enter, you often get a richer set of autocomplete options. This speeds up writing forms and helps you discover common input configurations quickly. Inputs usually come with a few important attributes. Type defines what kind of input it is, like text, email, or number. Class is mainly for styling. ID is a unique identifier, and it's especially useful for connecting a label to its input. And name is crucial. It's the key that determines how the data is sent to the server when the form is submitted. Type equals text is the most general option. It's used when the user needs to enter string data, like alphabets, words, or a full name. This is the default style of input, where you can type freely. If the field is meant for an email address, you can use type equals email. The idea is that the input expects an email format, typically containing an @ sign. In many browsers, and especially on mobile, this can also improve the keyboard and validation behavior. For phone numbers, type equals tel is commonly used. It signals that the field is intended for telephone-style input, and on mobile devices, it often brings up a keypad that makes entering numbers easier. For dates, type equals date is very useful because it can show a calendar picker. Instead of forcing the user to type a date format manually, the browser can provide a full calendar interface, which reduces mistakes. For time input, type equals time can bring up a time picker. On mobile devices, this often appears like a clock interface. The main benefit is better user experience and fewer formatting errors. Type equals number is meant for numeric values. It restricts the field toward numbers rather than general text. This is helpful for things like age, quantity, or any value that should be numeric. If you only place input boxes, the user may not know what each box is for. Labels solve that by describing the purpose, like full name or email. Labels are for clarity on the page, but by themselves, they don't fully connect the input to a specific identifier unless we use for and ID. To connect a label and an input, the label's for value must exactly match the input's ID. The ID should be unique on the page. Visually, it might not look different immediately, but this connection becomes very important for usability and for later development work. When for and ID match, clicking the label automatically focuses or selects the input. That's a big usability improvement. If they don't match, the label becomes just text, and the user must click directly inside the input field. For IDs and names, it's best to avoid spaces. A common convention is using a single word or connecting words with an underscore, like phone_number. This keeps your attributes consistent and easier to work with. To improve layout, inputs are often made full width so they line up neatly. And if the text feels like it starts too close to the edge, padding fixes that. A common approach is adding a width of 100% and horizontal padding so the typed text has breathing room. Not all inputs are text boxes. When the user must choose exactly one option from a small set, like male or female, you typically use radio buttons. Radio inputs are designed for single-choice selection. For radio buttons, it's also helpful to connect each option's label to its input using for and ID. That way, the user can click the word male or female, not just the small circle, and the correct radio button gets selected. If you set up radio buttons without grouping them properly, you can end up in a situation where both appear selectable independently. That defeats the purpose of radio buttons, which should allow only one choice in a group. The key to making radio buttons behave correctly is the name attribute. When multiple radio inputs share the same name, like gender, the browser treats them as one group, so only one can be selected at a time. When a form is submitted, the server receives data as key-value pairs. The name attribute is the key, so if the radio group is named gender, the submitted data will include something like gender equals something. The next question is, what exactly is that something? That comes from value. If you don't specify a value for a radio input, many browsers will submit a default value, like on, for the selected option. That's not very meaningful for the server, because it doesn't clearly say whether the user chose male or female. To send meaningful data, you set the value attribute. Now, if the user selects male, the server receives gender equals male. If they select female, it receives gender equals female. This is critical. The server trusts the value you define, not the label text the user sees. A really important point is that the server doesn't read the label text, it reads the value attribute. So if you accidentally set the male option's value to female, then even when the user selects male, the server will receive female. That's why value must be set carefully. For text-like inputs, the value naturally comes from what the user types, so you don't have to set a value attribute unless you want a default. But for radio buttons, the user can't type a custom value, so if you want meaningful data, you must define value yourself. You can also set a default value for a text input. If you set value equals something, it appears pre-filled. The user can still remove it and type something else, but if they submit without changing it, that default value is what gets sent. The material also points to another attribute, placeholder. Placeholder text is the light hint shown inside the input, like enter your email. It helps the user understand what to type, but it is not the actual submitted value. Only what the user types becomes the value. To wrap up, input type controls what kind of data entry experience the user gets. Labels become truly connected to inputs when the label's for matches the input's ID, and ID should be unique. But the most important attribute for submission is name. It's the key used to send data to the server. And for inputs like radio buttons, value is what gives the selection meaning. The overall goal is simple: collect correct data and submit meaningful key-value pairs.